Hello everyone. So today, this is actually my first video of this channel, which is Victor's Lab Notebook, and I'm Victor. So what I'm going to be doing today is I'm actually getting the incubator ready for some algae that I'm getting. It's out for delivery, and I got to make sure it's ready to go. So I actually have to get the incubator warm, which it's warming up right now, and I need to get the media that's going to grow in prepared and put in there. That way it gets up to temperature, so when I put the algae in there, it doesn't end up getting shocked by cold water. And it needs to be about 30 degrees, between 29 and 30 degrees. And it's a pretty simple process of, right now I'm preparing the media that it will grow in. It's a mixture of spirulina. I'm growing algae, spirulina algae. It's a mixture of a spirulina culture salts, which I get at Algae Research Supply, and also some nutrient media, which is a bunch of, these are a bunch of different salts, magnesium sulfate, essentially baking soda, salt, and a bunch of stuff to kind of simulate seawater. And this is has a bunch of nutrients, including trace metals like copper sulfate, magnesium, all that kind of stuff in here. And what I'm going to do is I'm going to add distilled water, 500 milliliters of distilled water. I'm going to put a stir bar into this jar here. To this, I'm going to add 500 milliliters of distilled water. And I'm following a protocol that's in this lab notebook right here. And 500. Now, normally to do any sort of measurements, I would use a graduated cylinder because they're not as accurate as a graduated cylinder, but because of the nature of this, essentially the water level is going to change, and I'm going to have to keep adding water over time because of evaporation and so on. And so whether it's off by a few milliliters, it doesn't really matter because it's not going to stay there anyways. But normally, to measure things out, you wouldn't use a beaker, you would use graduated cylinder, because then you can get better accuracy. Now, one thing I'm going to do is I'm going to mark the 500 milliliter point. That way I can keep the level the same. And now I'm going to start to add the salts. I'm going to get the stir bar stirring. And I need, let's see here, 7.5 grams, so I'll put that on there. Now, one thing these culture salts, one thing it does is it actually adds some carbon to the water. Essentially, it keeps the carbon level higher so that the spirulina can intake carbon dioxide, and which will help with photosynthesis, and it keeps the pH level up, as spirulina likes to have a pH of about 10 to 11 to keep it happy. This is actually why you hear there's such an issue with, when it comes to climate change and acidification of the oceans, is as the pH level drops, again, as pH level drops, the acidity increases, or because the acidity increases, the pH drops. As the pH drops, different sea life like algae have a harder time living, essentially. The thing is, algae produces a lot of oxygen and sinks a lot of carbon in its body, and then eventually it dies and sinks to the ocean floor, where the carbon gets trapped. And if all of a sudden you have a bunch of algae dying because the oceans are too acidic, well, then you got a problem. You end up with less oxygen produced and a lot more carbon dioxide staying in the atmosphere, which will, that's one of the issues with climate change, is it's not just a linear issue. It's not just X amount of carbon dioxide put out means this much damage, it's like a snowball effect, because the effects of climate change cause further climate change, because then rainforests aren't you end up with rainforests that aren't growing properly. You end up with droughts. You end up with algae dying because of acidification of the oceans. And all these different problems compound themselves each other, and then you end up with like an exponential growth in problems. Part of my research with the algae is related to climate change. I'm not sure how yet, but I'm working on trying to get algae to essentially absorb more carbon than it normally does. But while that's doing its thing, I need 1 milliliter of the nutrients and trace metals. And I'll let that kind of do its thing while I put some stuff away. One thing that's really important when you're doing stuff with in a laboratory is to stay organized. It's like the second things go awry, it's very hard to get your stuff organized again. It's really important when I'm dealing with some of the stuff I deal with. I deal with hormones, which, like, even a few molecules are enough to affect an experiment. So this is all pretty much mixed. I can now turn that off. And then I'm going to place it into this incubator here. So that's pretty much it. I'm going to put it in here, and I'm going to set up a line that aerates the water, or the media, and that's it for now. And then later on I'll be placing the algae in there. Thanks for watching.